All right, welcome everyone to the Singapore FinTech Festival. My name is Shantanu Dutt, joined by one of our AWS customers. It is Jason that you see. And we're going to talk about learnings from Amazon and AWS and use of machine learning and analytics and operational efficiencies. We'll also see sort of an actual use case from Jason later this morning after I'm done, and then we're happy to take questions as well. So if everyone can see my screen and everything's working well, let's get started. So what we thought we'll do this morning is, look at learnings from Amazon's efficiencies. This is not about Amazon products and services, but generally how Amazon runs its fulfillment centers and its website, and use of machine learning and analytics in that. And why we're talking about this in the FinTech Festival is because we believe that a lot of banks and FinTech companies have taken inspiration from this to apply some of those similar tenets to their apps and their websites and their use cases across insurance, banking, retail, or even otherwise. My Twitter handle is up there, so if you enjoy my talk, you have some comments, feedback, I'm more than happy to connect with you offline as well on my Twitter handle. Now, at Amazon, we call ourselves a day one company. A large part of our culture, and I've been here for a little over 9.5 years. I'm the head of technology for the Southeast Asia region. A large part of the reason why my journey has been successful in a company is because of the culture, which is that of a day one culture. That is, we are always working and seeking to experiment, innovate, look at an MVP, iterate on it by taking customer feedback, and move on to the next experiment, the next MVP, and so on and so forth. And a part of our business model on the .com side, and this can really apply to most companies, a lot of banks come to us and say, Amazon is at the bleeding edge of technology. What's next with innovation, right? What are the 10 things that are going to change with Amazon in the next 10 years, right? And when I go to, banks and financial services companies and fintech companies, we tend to talk about the same thing. What are the things that are going to change? And I can bet you that almost no one talks about things that are not going to change in the next 10 years. Because you can base a business model on things that do not change rather than things that do change. And if you look at our flywheel, and this is available on the web, 20 years ago, we came up with this business model saying this will be our business model, literally. And as the legend goes, Jeff Bezos drew this on the back of a napkin or a tissue paper, which is basically using tenets that will never ever change in our business, no matter what happens, which is we strive to give customers better customer experience, our online shoppers on the Amazon.com website, that is, which will lead to more traffic. And with a large number of customers, we'll have a lower cost structure by achieving economies of scale. And then by having the lower cost structure, we will pass on those cost savings to customers and so on and so forth. Now, if any part of this flywheel is affected positively or negatively, the entire flywheel gets affected positively or negatively. And whenever we think of innovation, we think of these distinct tenets to think of which part of the flywheel this innovation will affect on. But it's basically based on things that will never change at our very core. A lot of people think that Amazon is very futuristic and does a lot of innovation, but the reality is on the baseline, the innovation, the way we think about it, is on things that will never change in our business. 20 years from now, in 2040, I find it impossible to believe that there'll be customers who basically say, you know what, Amazon is great. I wish the customer experience was a little worse than what it is right now. Impossible, never going to happen. Or Amazon.com shopping is great. I wish the pricing was a little higher. I wish it was a little more expensive. Never going to happen. And this is sort of our business model, and our formula for innovation, probably one of the most overused terms in the industry today, innovation. Everyone wants to use it. Everyone wants to add machine learning and analytics and innovation to just their talk track. But really, internally in Amazon, for us, we almost put a formula to innovation. And a lot of customers think about this and look at the first time and almost laugh at it. What? Like, really, there's a formula to innovation? Well, it works for us in Amazon. And I'm not claiming that it works for everyone else just because it works for Amazon. But a lot of our customers, including in the financial services space, have uptaken some parts of this formula because it's worked for them. And to us, our formula for innovation that has worked for us for many, many years is our organization structure. So the way we are organized as a company in terms of employees, how we are structured, into architecture, that is how our services and our systems are architected, which is microservices culture and there, raise the power of mechanisms that we have into culture, right? And I'm going to sort of generally focus on the top two ones for this session, which is mechanisms and culture. I'm doing another talk track about an hour from now in the FinTech Festival for developers, which focuses on the first two on the baseline, which is organization structure into our microservices culture. Uh, and so if you're interested in the other one as well, you can join there. But in terms of culture, the first thing that we do as a digital company, right, in the digital space, in any business, we believe there are two things that most successful companies, including digital banks, have done to survive well in this space and innovate and disrupt. And the first thing that they do is use actionable metrics because that is what is the beat all die all in the digital world, which is using the right metrics to actually action it for on behalf of your customers. And what I mean by that is there are a lot of companies even today that actually look at metrics like total number of website hits, as an example, total number of registered customers, for example. Do you know that at Amazon.com, we don't keep a track of any of those metrics? Because think about it, it doesn't tell you anything about your customer. Total number of website hits or app hits. So what? How many of them actually translated from click to checkout of the shopping cart to payment to revenue, right? Total number of registered customers. So what? How many of them were active? How many of them were actually shoppers in the last 30, 35 days, without which maybe they will never shop with Amazon for a certain product, and so on and so forth. And so rather looking at these vanity metrics, what we rather do almost always, and we've been doing it for years, is do A-B testing. And we do A-B testing at scale, which is for a particular product, we expose that product with a different pixel size, with a different buy button. Sometimes it's just a small case of placing it on the left hand side versus right hand side, for example. And we expose that change of the product for online shoppers to about 90 to about 0.5 to 1% of our customer base in a particular city, in a particular country, in a particular Amazon marketplace. And based on clickstream analytics, we then track customers saying whether this is successful. And then we actually run that entire change for the remaining 99 or 99.5% of our user base. And if it's not successful, when people are not interested in that change, based on our clickstream analytics, we work backwards to say, well, you know what, this doesn't work. Guess what? No one notices because it's a small blip. And then we move on to the next experiment and the next experiment and so on and so forth. And doing these experiments gives us the true behavior of human beings that are shopping on a website. And it's much, much more intuitive and much, much more tangible in terms of outputs we look at. I'm told that in 2018 alone, Amazon.com ran about 24,000 plus experiments on some of its marketplaces. And that's why the personalization that we do for customers is so successful. There are banks like Commonwealth Bank of Australia and other banks that run on AWS that basically do the same for account opening. And so what some banks do in Australia is look at for account opening for the first time for a user, you need to have 5 clicks, right? So with 5 clicks, you should be able to open an account in your app on your website. And it should take you between 3.5 to 4 minutes to open an account. And every time a user takes more than 5 clicks and more than 3 to 4 minutes to open an account, that's treated as a defect by some of these banks. And then they work backwards to say what went wrong that it took the user more than 5 clicks and more than 3.5, 4 minutes to open an account. Was it the layout of our website which you need to change? Can we start doing A/B testing for certain users and change the layout and so on and so forth? And the vision is still every single user on this planet opens an account with 5 clicks and 3 minutes of time. We will continue this testing. And that's very similar to what Amazon.com does in terms of doing experiments and working backwards from online shopping users to give them the ultimate personalized experience. Now, some of our customers outside of banking industry as well have been using our platform in interesting ways, which is AWS. Domino's Pizzas, which requires no introduction if you're into pizzas, did something really, really interesting using data as an experiment. And what Domino's estimates is even before COVID-19 hit us, 70% to 75% of all their user base, that is their customers who order pizzas and eat pizzas, in certain countries like Australia, for example, is online, which is not surprising. So very few customers go inside the stores to eat pizza. Most of them order it online. Furthermore, during COVID-19, almost 100% of the customers became online for unsurprising reasons that we all know. And so what they did was used machine learning, and I won't go into the technical details, but they used machine learning in a very interesting way where they looked at customer data and they figured that there are certain patterns that their customers are behaving in a certain way. So, for example, on a Thursday evening, if it's raining in a suburb in Sydney, in Australia, there are chances are high that you might just get a lot of customers ordering margarita pizzas with extra cheese at 7 p.m. or 7:15 p.m. in a particular locality, right? That's just an example, for example. And there were many such permutation combinations. So what Domino started doing as a part of Project 310 is from the central office, started pushing push notifications to the screen of the employees in the store who actually bake pizzas, to actually at 7 p.m. on a Thursday evening, if it was raining, to with a message saying start putting margarita pizzas with extra cheese on with certain toppings of a certain crust and a certain size in the oven, even before a customer had ordered that pizza. And so what they were doing was they were preempting customer orders and they were predicting customer orders before that using machine learning. And 15 minutes after that, at 7:15 or so, when the pizza was ready, and coincidentally or preempting as a part of the model, customer orders came in, the pizza was ready for delivery. And so a lot of customers were wondering, what's wrong? I just ordered a pizza and within 5 to 7 minutes I get my pizza. Am I getting a stale pizza? Customers started suspecting that. The reality was it was basically machine learning doing the work on behalf of Domino's Pizzas, trying to predict and preempt pizza deliveries of a certain type at a certain time in certain localities. And it worked. It wasn't 100% accurate because the way things work with machine learning, sometimes there was wastage, but over time it became more accurate. And they announced in one of the results, quarterly results this year, that Domino's Pizza sales have gone through the roof simply because in a COVID-19 lockdown situation, a pizza delivery brand that can deliver pizzas at fastest will have the edge versus other competitors. And so that was a great example of using data to run an experiment. The last one I would cover as an experiment, this is really interesting. I don't know how many of you know this, but Amazon India, the retail arm of Amazon in India, was the fastest ever entity of Amazon in the history of 25 years to cross $3 billion in revenue. Right? So this was faster than US. So Amazon.in, the India arm of the retail giant Amazon.com, basically was the fastest to cross $3 billion in revenue, faster than the US marketplace. Now you might look at that statistic and you might go like, well, India has a lot of people, 1.3 billion people, so potentially a lot of online shoppers, so that was easy. Not true. India has a lot of challenges, just like ASEAN, which is basically lots of problems with connectivity. So, people ordering things for shopping and then those trucks and bus tempos going around to tier 2 and tier 3 towns where connectivity is not the best to deliver those goods. And then, more importantly, from a pricing perspective, just like ASEAN and Singapore and other parts of Asia, it's an extremely cost sensitive market, very cost sensitive. And so what Amazon.in had a dilemma of when they were launching in 2012, 2013, is that how do we launch a marketplace, a shopping marketplace, where we have to be careful of the price, but we don't just launch just like that with throwaway pricing because customers had our competitors, our e-commerce competitors had a loyal customer base in India because they had launched earlier. So what they did was along with launching Amazon.in, they also launched something called as Junglee. And Junglee was basically a e-commerce aggregator portal, except that it was owned by Amazon as well. So there was Amazon.in that was owned by Amazon, and there was Junglee, which was also owned by Amazon, which is a price aggregator website. And so I thought it was a great experiment to collect data because what they did was if you went to Junglee on the search engine and type for iPhones, it would basically compare iPhones across all e-commerce websites in India, including Amazon. And If there was a better price or availability found on another e-commerce website, then Jungli would redirect the online shopper and the users to an alternate e-commerce website, which is not Amazon, because it is a better price or better cosmetics or better availability there available. And so people wondered, why is Amazon doing that? Like, what's the point? We are losing out on sale by redirecting users to a competitor website. But the reality was, because we owned the website, we could track the customer journey, that is clickstream analytics, end to end, which means short term we were okay to lose out on a sale, but midterm to long term, we could exactly look at customer behavior to know what is it that dragged the customer to a competing website? Was it just purely price? Was it the cosmetics of the iPhone placed on one side of the website was more attractive? Or was it the seller or the iPhone version availability? Which means because Jungli was a pull factor, it was a price aggregator, so it basically pulled in a lot of online shoppers in India. It basically became very easy for us to track user behavior online. And then over time, we basically then aggregated all that behavior to actually make changes to our Amazon.in website on pricing and our sellers and availability, etc. And then over 3 to 4 years, we studied the entire market. So it was sort of a great example of actually launching a price aggregator and short term, maybe losing out on a potential sale, but using data online and tracking clickstream analytics and the digital footprint of users to actually use that to drive decisions. So that was about iterating at the right metrics and looking at the right and actionable metrics by using experiments. The second thing that most customers that are successful that they do after they launch the MVP in the digital world is iterate at speed, iterate at massive speed. Now, I don't know how many of you know this, but in Amazon.com, we obviously have thousands of developers in our headquarters in Seattle. But the frequency of deployments of software updates in the backend, the mothership of Amazon.com, is once every 6.6 seconds. So on an average, on certain weekdays or weekends, we actually deploy software updates once every 6.5 seconds, which is massive, right? Now, if you're interested in knowing how we actually manage to have this speed at Amazon.com, I'm covering this in our next session that I'm talking about 1 hour from now, in the session for developers, which is how a microservices culture and an org structure helps actually drive this efficiency, which is iterating every single time. Now, taking the DevOps, I guess, inspiration, a lot of our banking customers have started using a lot of DevOps model and started using efficiency and baking that for their developer productivity as well in banks. For example, Macquarie Bank in Australia did something really, really innovative and cool. What they did was to ensure the developers are productive and they were spawning up and down their developer environments in the cloud just in time. They basically gave the developers their badge on their ID cards, on their badges, a small YubiKey-like interface which they were attached to the badge. So when developers are walking into the branch, their office, their corporate head office, and walking in, and when they swipe their badge, that small token or the YubiKey-like interface basically send an API call to AWS to spawn up the developer environment of resources on the cloud. And by the time the developer reached his or her desk, the environment was ready and ready to go. Same the other way around. When they were leaving in the evening and leaving for home, and when they swiped the badge out, it basically sent an API call to actually spawn down the resources. And by doing that, they had multiple, benefits and upsides. Uh, you know, uh, Spawning just-in-time environments for the developers from a cost perspective. From an auditing perspective, it would make perfect sense because from a regulatory standpoint, you're actually tracking a developer coming in, but also where the API call was met for, what time the cloud resources are up and running and down. And so from an auditing perspective, it just makes sense and productivity increased. Similarly, a lot of banks in Australia and now some banks that I can't name in ASEAN are following a complete infrastructure as a code model on the cloud. And so things like using code to spawn up infrastructure on the cloud. A lot of banks have taken a cue from Netflix and taken their open source, what they call as Chaos Monkey, into account. And Chaos Monkey, by the way, is basically a tool which basically tests your high availability. So if you have a really, really highly available requirement on your website or your asset, Chaos Monkey will basically test that by randomly pulling down infrastructure. And the idea there is in production, some of these banks that are using this is to test your availability and to really test in production live rather than doing a monthly checkpoint test of your DR and availability. Test how resilient your website is and how highly available your applications are by not having single points of failure. And so those are things that people have started doing on the cloud and started building an efficiency. And that's how they can actually iterate by releasing updates to code and their versions every single day. Now, that was a bit about culture in terms of looking at the right metrics and looking at and iterating every single day. Now, I'm doing a shortened version of this. Obviously, if any of you individually are interested in doing like a digital innovation the way Amazon does it, just contact us separately. We're more than happy to do that for your organization. Let's move to the second part of my presentation before I hand over to Jason, which is mechanisms. Now, at Amazon, what we say is there's no point having a culture if you can't sustain it because we are hiring hundreds and thousands of people every single day. And one of the mechanisms that we have is that of a press release, which is before every innovation starts. And if a product manager or a person has an idea, even before we start developing it, we basically write a press release to ensure that we are thinking working backwards from the customers. And working backwards is this theory where we're writing a press release, imagining a customer, even before we started developing the product, so that we can actually imagine what the customer persona looks like and then work backwards from there. And once the press release is approved, that's when we start actually developing the product, right? So we assume there are no constraints that helps us think big. And there are lots and lots of innovation we have discussed and lots of customers that we work backwards from to discover things that we wouldn't have had we not followed this working backwards process. For example, a lot of financial services industries are also working backwards to actually look at customers who use their app to see what they're using for, or even general insurance and fintech companies in the insurance space. Now, in the Amazon Fresh world, so into groceries. Now, I don't know about you guys that are attending this, but I personally happen to be a person that's a foodie, but I really suck at the kitchen. I have no idea how to cook meals in the kitchen because I just can't cook. It's just not an interest of mine. But I do love eating. Now, what happens there is when I actually try and shop for food or shop for groceries online, it takes me an inordinate amount of time to actually shop for groceries because I don't know what groceries go into what meals. All I know is that next week, Monday to Friday, I might cook some meals for lunch and dinner, those 10 meals, but I don't know what groceries go into making it. And so it turns out there are lots and lots of thousands of people on this planet like me. I was shocked. I thought I was unique. And so by looking at clickstream analytics, what Amazon Fresh did was figured out that why is it that some people take longer to shop for groceries versus other people? Why are they sort of wandering on our website before they shop and check out? And so it turns out that this was a problem. So what they did now, working backwards, is wrote a press release for a product, and now it's live in the US. And what they did was very smart. They integrated the Amazon Fresh app with another app called as allrecipes.com. So All Recipes is a recipe app in the US. And so now you have the option of going to the integrated app where it makes it really easy for you to shop. You can see a bunch of recipes or meals that you want to cook. All you have to do is click on those meals or those recipes, and your Amazon Fresh shopping cart will be pre-populated with the ingredients and groceries required to make that meal, right? Which means shopping for groceries becomes seamless. It's almost like going to a restaurant, looking at the menu card and saying, this is a meal I want to have. And the ingredients required to make that meal are being loaded in your Amazon Fresh cart. And then you have a choice of making the adjustments of removing certain things or adjusting the number of people you want to cook a meal for, etc., etc. And then if you think about it in the future, this does wonderful things to supply chain. If every single person started using this feature from a supply chain perspective, that is that many less SKUs that we have to take care of. All you have to take care of is what is the most popular menu. There are other banks that are basically using the same concept to take an outward view to innovation. You know, a couple of banks have launched what we like to call as Dev Exchange or Data Exchange, just like Amazon has internally a big data marketplace, where they have sort of a sandbox where they expose this to developers And by certain criteria, when developers participate in that dev exchange, what they can do is look at data that mimics real-time data of a marketplace or a trading platform, and then it allows them to experiment and develop new features. The hope is that someday this will boost innovation because imagine people who play with almost real-like systems look at patterns of customer spending or trading platforms, etc., and they develop their personal algorithms around personal financial management and consumer spending patterns and think how customers can spend more money. And then once a pattern or an algorithm is selected by the bank, they can then sort of buy that or have a revenue sharing basis to then build a new product via an API model in the future. And then lastly, what does this culture of innovation do? We believe it leads to a lot of use cases that are really, really wonderful. Computer vision, as one example, has become so easy to develop because of it being available on the cloud. And Jason is going to talk a little bit about that a little more later. But computer vision in general is used much more pervasively than you think today. In the Amazon warehouses, so in the back end, our fulfillment centers, when you actually order a product, the computer vision system basically looks at, so we have machine learning enabled cameras, and as soon as the order comes in, rather than an employee in the FC looking for certain products as to where it's stored, there's a machine learning enabled camera which basically pinpoints a laser beam right at the rack and the shelf where it is stored. So a person can go there, pick it up, and then give it for shipping and packing and delivering in the next step, which means every single minute saved of searching their product is huge savings for us in a day because we ship millions and millions of products in a day. And that wouldn't have been possible without computer vision. Another obvious example that financial services companies are using is looking at fake currency detection, which is basically looking at currency and pictures and then finding out easily as to what currency is fake rather than a human being or machines using it, because computer vision is supposed to be much more accurate, much more cost effective and easier. There are other, I guess, intuitive ways that customers are using things like Amazon Sumerian, so AR, VR, right, or interactive AR, VR technologies. So for example, a telco in Malaysia called as Maxis is using this in a really interesting way, which is basically looking at installing a monitor in one of the branches in downtown KL, where a 3D avatar made with Amazon Sumerian greets you when you walk in as a customer. You can basically scan your mobile with a QR code and this person greets you. And in the future, what they're looking to do is basically convert this into a Lex bot or add conversational interfaces. So when a telco customer walks in, knowing the registered mobile number, this bot in a 3D avatar view with a local accent will start talking to the customer, start asking the customer what are their preferences, what is it that they have come to the bank for. And by the time the customer actually goes to the actual customer service desk, chances are 70 to 80% of the customer's queries are already resolved because there's a digital interactive system that's already working in play. The Union Bank in Philippines is doing something similar. Apart from having robots in the bank, which are machine learning enabled, so they basically actually lead you to the right counter, they also have a Sumerian-led digital interactivity in their banks. And the other thing that they're working on as an experiment in the future is potentially do sentiment analysis by having overhead cameras and finding out whether people are going out and walking out of the branch happy or sad or not satisfied or angry and judge the customer sentiments rather than actually giving them a survey form and having to have them fill questions, because that's much more intrusive to the customer. That's all I had to cover. The only thing I would probably add is all this innovation from Amazon.com is really possible because of AWS, the underlying platform on the cloud. And before I hand it over to Jason, what I thought is, since we're talking about computer vision, what I'll basically do is over the next 2 minutes, show you a very quick demo on computer vision. And we are working with a couple of insurance companies or car insurance companies who basically trying to define the next generation car insurance. And this is just a demo I built with my team, and it took us like half a day to build it really. So what we think is, car insurance is a complicated space. It's remained similar for many, many years. And what happens is if you have a damaged car and if you have an accident, God forbid not, you basically call the police, file a police report. You basically call your insurance agent, have that person come in, look at, take pictures of your damaged car, file a report, give you an estimate, then you go to your workshop to get repairs, etc., and you don't even know whether the entire process, which is manual, is taking you for a ride, is the estimate correct, and it's much more time consuming. And so hopefully in future, some of the customers that you're working for, the car insurance space might look different in the future, which is if you have a portal like this, and this can be a mobile app as well, you can basically submit as a user pictures of your damaged car. So what we did was we built a machine learning algorithm, a model, and I'm uploading a damaged car picture. As you can see, it basically has certain scratches. It's not really major, but as I'm submitting this picture, it's basically making an inference request to an ML model on the AWS cloud as I'm talking live. And then the machine learning model has already been trained with thousands of car pictures. And what you see now, as you can see here, is it's done a validation. It's recognized that the damage on the car is on the side of the car and the severity is minor, right? And this is because the ML model knows and has been trained with thousands of pictures. Now, if I take another example and then upload a picture, oops, this looks bad, a picture that is a really major damaged car, and I follow the same process, I submit this and upload this to the AWS cloud, it's making an inference request to the same model, and hopefully the output should be something different, simply because the damage is really different. And as you can see, it's detected that the location is now in the front, not on the side, and the severity is much more severe. Now, I just had half a day to create this demo, and we made this rudimentarily. If I had more time, you could literally go into details of creating many more fields on what the quality of the paint was, what the model of the car was, etc., and what the estimate of such a damage would look like. And so in the future, it will become much more automated and much more seamless to claim car insurance damages without really involving human beings to a large extent and making the entire manual process completely automated. That's it from me for now. I will turn it over to Jason now for the remaining 10 minutes before we take Q&A.
Thank you, Santanu. Look, it's great to be talking to everyone today. Thanks to Oxygen by APX for this, the opportunity to talk to you. What I'll quickly go through today is we've been thinking about, how we drive efficiency into the business. So my name is Jason Noorman. I am the Chief Technology Officer for Pepperstone Group, and I'll just quickly swap to the slides. Of course, it never goes. All right. So as I said, I'm the Chief Technology Officer for the Pepperstone Group. So the Pepperstone Group, we're a digital native business. We've been partnering with AWS really since 2010 when we started a business. Just so it kind of puts a feel on what we are and what I'm about to talk through. So we provide retail clients with access to Forex indices, equities, etc. We're considered today to be one of the largest retail OTC derivatives, Forex and contract for different providers in the world. And to put us to put us into scale over 10 years, we're now servicing over 110,000 retail trading clients, and we process on average about 9.2 billion trades per day. Now, for those of us that are in financial services, everyone recognises that one of the really important processes we have is how do we actually identify our clients? How do we identify that they're legitimate, particularly when everyone's coming in over the wire? One of the services that we provide and the things that we really do is particularly in our industry, our anti-money laundering and our KYC, or our know your customer obligations, we take very, very seriously. So one of the things that we do is we take thousands of documents every single day. Now, extending on kind of what Santanu was talking about the machine learning, we had a bit of a thought that we wanted to try. Now, processing these thousands of documents, there's a few things, a few challenges that come up for us. So I sat down with our machine learning team and some of our developers and said, look, there's some technology that's beginning to emerge, particularly in the world. Here's what we wanted to do. The first thing was, we get documents where someone may find a document on the internet, they go and change a few little pieces. And so what we wanted to say is, have I seen this document before? Have I seen something very, very similar? How unique is this document? Because one of our customer service agents that might be processing our AML, documents may have seen a document 6 months ago, but they're never going to remember. The second thing we wanted to do was really start to use some of the advanced kind of machine learning techniques, particularly around error and, error level analysis, it's called, and that's up on top of TensorFlow. So how do we apply, so a document comes in real time, how do we actually know if that document's been edited? Could we possibly find out? The third thing that's really important to drive efficiency out of the process is that we actually needed to embed the document processing into our existing pipeline. And what I mean by that is instead of having incoming documents go to a human to actually kind of assess, we wanted to do a pre-assessment with the machine. So those that definitely passed the test could automatically go through, and those that were marked as suspect documents or had a very strong correlation to a previous document, we wanted to look at that. Now, from one of the examples, and so I'm just going to quickly talk through some of the things we had to do to achieve that. Now, for that, not everyone who's into machine learning and really understanding what a great regression model is, one of the things that we had to do was how do you teach a machine to identify a document that has been manipulated or a document that, a document that's manipulated or one that's we've seen before. One of the ways that we had to do that is we took a library, and there's some very, very good open source libraries. So we had to basically say to the machine, when you see this document, we want to notice if it had been edited. The way we do that is we take 5,000 good images and we actually train the machine to identify what a good image is. Now, as you can see from the example on the screen here, there's lots of good images. We know that they haven't been edited. There's a few characteristics about images because machines can't recognize cats or dogs or buses. What it does recognize is the noise filter from the sensor in a camera. And so you get a little bit of noise across the image. It can identify the edges. You can identify a whole lot of nuances in the pattern. So now that we've identified the good images, we then set about and we have 5,000 completely edited images. Whilst these have got very little to do with passports or bank statements or utility bills, what this does is you can clearly see here as a human, you can say a bus sitting on a cat, that's clearly not right, or a dog on an airfield or a plane, or a car flying above a ship, they're clearly bad. What we can do from that is that we can actually train the machine to say when there's something that's different or not quite right, using error levels and also looking at the pixels within the image, we could actually train the machine to identify fraudulent images. Now, it's quite an interesting process. So for us, the original work, as you can see here, we started the model and we were doing 40,000 iterations in a machine learning sense. And the first model we built took about 180 hours or 7.5 days running flat out. Now, from a development cycle to wait a week to see if you kind of got it together is not good enough. So one of the things we made the decision to move across onto the Amazon SageMaker product. And with SageMaker being the machine learning, you could see that we could take advantage of a Tesla V100 processor, 16 gigabytes. It ran effectively at 100%. We used about 400% CPU, and we could take that 180-hour machine learning training job from 180 down to 6.5 hours, which gave us just a ton of efficiency. What that meant is that we could basically build and prove out a model every single day so our developers could become, much more productive. Now, the interesting part in this is, what did we get out of it? So here's a quick thing. We basically call it our document X-ray. We have our legitimate image, which was provided to us, on the right-hand side. And what you can see on the left-hand side in the color gradient, the brighter the green is, the more it's been edited. So whilst to the human eye, the document on the left-hand side looks like it's not very edited, but what you can begin to see, so we can very quickly identify where there have been lots of edits, particularly on this one document. Our machine would tag this as a document that can't be trusted, and then we would go through our KYC processes and our AML processes to decide what to do with that document. So what we got is we can now X-ray documents. The other thing that we wanted to do in the second part of our challenge was when we get all of our documents, let's say that someone's bought a shopped document off the internet, they've gone and changed some of the text in this example. What it does is it basically comes through, and we've worked out a way using some very advanced process to say, how can we say that this document is have I seen it before? What's the document similarity? Now, this isn't just hashing the document. When you change one byte, the hash changes. This is looking very specifically and creating a digital fingerprint so we can determine just how much the document's changed, we can combine that with has the document been edited, and very, very quickly. The example that you can see on the screen now is you've got some very, very minor changes. If you look carefully, you can see the numbers changed, the names changed, but they've left all of the amounts and everything else the same. They might have zoomed it in a little bit, trying to confuse us, but because it's kind of working on a fingerprint. So we put this into production. We thought, let's give it a go. Now, using because we're effectively a complete Amazon backend, we could roll this out sort of very quickly. And what we found is very quickly, we found similarity in lots and lots of documents. When you're taking thousands of documents every day, to identify each one of these individually is a really hard task. But you can see some days we'll get one, some days three. But you can see in the teal color there, we can see a similarity score. So we get a lot of documents which we've actually seen before. It's not specific to any one country. We get it a lot around the world. It's just the world that we operate in. So our job as a broker is to understand that our clients are there. Now, the second thing is driving efficiency. If we are to use Amazon SageMaker, and we're using some of the best technology available and some of the biggest technology, one of the challenges that we really wanted to face was it can become expensive. So we work with the AWS architects and the team locally, and then what we could do from there is that we worked out a way that we could use Amazon SageMaker and all of its goodness to build our models very, very quickly, and Amazon just could help our data scientists and our developers. We could build, we could train, we could deploy, and that was fantastic. However, when it comes to the operation, one of the things I didn't want to do was I didn't want to stand up a set of servers and a set of production applications that would run effectively on a 24/7 basis. What I wanted to do is we've used the AWS Fargate service, which really allows us to use serverless compute. And what that did is specifically so we could take the models built in SageMaker, we could move them over to Fargate, and we could say via Fargate, we only want to use them via the container when we actually want to use it. So for the efficiency for us as a business is that we only use the compute resources we need, and they're fractions of a cent for the Fargate application. So like I said, Jason Noorman from Pepperstone, I'll pass back to Santanu.
All right. Thanks for that, Jason. Let me see if there are any questions coming up. We do have about 3 minutes left before we end the session. Epic's team, do you see any questions at all, just in case, ensuring that we're not seeing this incorrectly? Are there any questions that we can look at? I'm just looking at.
It appears not.
Okay. There are no questions so far. We'll just give it 1 more minute, just in case it's a last minute question, and then we'll call it a day. No questions so far. Yeah, I just want to ensure.
You must have been that thorough.
Okay, so looks like there are no questions. So then in that case, I guess, Jeannie, if you're okay, thank you, Jason, for joining us as well. And thank you, everyone who joined our talk. Hope it was useful. Have a good rest of the day and a great rest of the Singapore FinTech Festival. See you.
Thank you.